Well, hi everyone. I just wanted to go through some of these bookwork problems here. And from our textbook, we're simplifying trig expressions, pages 5, 13, and 14, and from that assignment, just working through that. Some of you requested that. And 21 is just a simplifying problem. And I see right here that we have common factors, so I am going to factor out tangent squared x from this term and from this term. And then I'm going to recall that sine squared x plus cosine squared x is equal to 1. And if I were to subtract sine squared x from both sides, I'm seeing that cosine squared x is equal to 1 minus sine squared x. Alright, so I'm going to take that out and put cosine squared x in its place. I'll put that in parentheses. And then I'm going to rewrite tangent squared x as sine squared x over cosine squared x, and I'm multiplying that by cosine squared x, and then that cancels out there and there. So that's equal to sine squared x. Now 23 is another factor and simplify, and it's secant squared x minus 1 over secant x minus 1, and this is a difference of squares, so I'm going to factor that way. I've got secant of x plus 1 times secant of x minus 1. That's how I can factor that, and that's over secant of x minus 1. And then I'm just going to cancel those two, and I get secant of x plus 1. And that's, I have simplified it. So 31 is just, they're just asking us to factor this. And I've got cotangent squared x plus cosecant x minus 1. So I have this expression I'm going to factor. But I really need the same trig function if I'm going to factor. So I am going to derive the one with cotangent and cosecant. So sine squared x plus cosine squared x equals 1. If I just divide both sides, or divide through, I want cotangent, so cosine over sine. So I'm going to divide through by sine squared x. And sine squared x over sine squared x is 1. Cosine squared x over sine squared x is cotangent squared x. And 1 over sine squared x is cosecant squared x. So I'm going to subtract 1 from that to get cotangent squared x by itself. So cotangent squared x is equal to cosecant squared x minus 1. That's what I'm going to put in here. So cosecant squared x minus 1 plus cosecant x minus 1 is cosecant squared x plus cosecant x minus 2. And I'm just going to kind of do a u squared plus u minus 2. If I were to factor that would be u plus 2 times u minus 1. Well, in the same way, that's the way I would factor this. Cosecant x plus 2 times cosecant x minus 1. Alright, 37 is a simplify. Sine beta tangent beta plus cosine beta. Alright, looking at this, I don't see a common factor like I did up here, so what I'm going to do is change things to sine and cosine. So sine beta times sine beta over cosine beta plus cosine beta is sine square beta over cosine beta plus cosine beta. Alright, I don't think we've done much to simplify that. When I have like a fractional expression, I think I'm going to try to make it into one fraction. So cosine beta, and this is over 1, I'm going to multiply this one by cosine beta over cosine beta, because when I do that, then I have sine squared beta over cosine beta, and this is plus cosine squared beta over cosine beta. I think I want to take this way this time. This is over cosine beta, and I've got sine squared beta plus cosine squared beta, and that's 1 over, okay, I'm just going straight through it and not explaining much, but sine squared beta plus cosine squared beta is 1. That's that identity right there. And I've got 1 over cosine beta, and I think that is secant beta. So this is equal to this. Alright, that's 37. 41 is perform the multiplication and use fundamental identities to simplify. So that's sine x plus cosine x, and we're squaring that. Now remember, a plus b squared is a squared plus 2ab plus b squared. I'm going to do the same thing here. So we're still using the algebras, but it's sine squared x plus 2 sine x cosine x, x plus cosine squared x. Just kind of analogous to what I did here. And then I'm going to rearrange. I'll have sine squared x plus cosine squared x, because we know what that's equal, plus 2 sine x cosine x. This part is 1 plus 2 sine x cosine x. All right. Since it's placed on paper, let's write on the other side. What do I have left here? 43, 49, and 55. Okay, 43. We're going to do the addition and simplify if we can. 1 over 1 plus cosine x plus 1 over 1 minus cosine x. I need a common denominator. So I'm going to take this one and multiply it by 1 minus cosine x over 1 minus cosine x. I'm going to take this one, and multiply it by 1 plus cosine x over 1 plus cosine x. And what do I have here? I have 1 minus cosine x. I'm going to make this one fact. Plus 1 plus cosine x over, that's 1 minus cosine squared x. That 1 plus 1 is 2. Those cancel. And remember, I'll rewrite this, but if we get the hang of this, we don't have to be writing this every time. that if I subtract cosine squared x from both sides of this identity, I've got sine squared x equals 1 minus cosine squared x. So this is sine squared x I'm replacing 1 minus cosine squared x with. And I could go one maybe step further. That's 2 times 1 over sine squared x, which is 2 cosecant squared x. This and this are equal. All right, 49. We want to write this so it's not in fractional form. Sine squared y over 1 minus cosine y. All right, my inclination here is to multiply this by 1 plus cosine y. Kind of the conjugate idea here. And what I'm seeing here is sine squared y times 1 plus cosine y. I'm not going to distribute that yet unless I see a reason to. This is over 1 minus cosine squared y, which we just did. So that's, I'm going to replace that with sine squared y. And you see those cancel, and I got 1 plus cosine y. 55 is next. And 55 is it. All right. So we have the square root of x squared minus 4. And we have x equals 2 secant theta. So the instructions say substitute this in. We have an algebraic expression. Substitute this trig expression in and simplify it as a trig expression. So I'm going to take 2 secant theta in place of x, square that, go minus 4, and write that as the square root. 2 squared is 4, secant theta squared is secant squared theta, minus 4. And they both have 4's, so I'm going to factor that out. 4 times secant squared theta minus 1. Alright, I got to derive again, because so sine squared theta plus cosine squared theta equals 1. I need a secant in here, so that's 1 over cosine. Sine squared theta over cosine squared theta is tangent squared theta. Cosine over cosine, cosine squared over cosine squared is 1. 1 over cosine squared theta is secant squared theta. If I subtract 1, I got tangent squared theta equals secant squared theta minus 1. So I'm looking at the square root of 4 tangent squared theta, which is the square root of 4 times the square root of tangent squared theta, which is equal to 2 tangent theta. And that's simplified. All right, there you go. I hope this helps. God bless you.